Hello everyone, and welcome to Biopedia. Today we're going to be using real-world data to go on another thought experiment, with the potential to discuss relevant research and a disagreeing answer in a subsequent episode. In terms of ancestry, with the potential to discuss relevant research and a figure which is different to the one we'll arrive at today in a subsequent episode. The thought experiment is this. In terms of ancestry, we have 2 parents and 4 grandparents. If we continue this, your number of ancestors double every time you go back a generation. How long would you have to go back before you would have more ancestors than there were people on the planet, at least hypothetically? Let's start off by defining a key term. When we're talking about a generation, obviously this can vary quite a bit. If we consider the very extremes, there is a reported instance of a Peruvian girl called Lima Medina who gave birth at under 5 years old in 1939. At the other end of the scale, Spanish woman Carmela Busada gave birth to twin boys in 2006 at the age of 66. Busada is currently in the Guinness Book of World Records as the person who gave birth at the oldest age. Obviously, these examples show that in terms of when people give birth, there is quite a bit of variation. So, let's define what we're talking about. Let's define what we mean. For our purposes today, we're going to be using the definition of a generation. For our purposes today, we're going to define a generation as about 30 years. Moreover, we're going to set our starting point for this thought experiment as being the year 2000 in terms of the birth of the person whose ancestors we're going to consider. This means that their parents would be born in 1970, their grandparents in 1940, their great-grandparents in 1910, and so on. For the second part of our discussion, we're going to talk about where I'm getting my population data from. The website Our World in Data has a chart for the size of the Earth's population. The website Our World in Data has a chart for the size of the Earth's population from 10,000 BCE until 2021. This data can be downloaded in the form of a CSV file, and has data going back every year between 1800 and 2021. After that, the data goes back every 10 years until 1700, and then every century until the start of the Common Era. Finally, the data includes every millennium back until 10,000 BCE. If we put these 2 datasets together, we can track what the population of the Earth was at the start of every generation. Once these 2 datasets cross over, we would then know when, theoretically at least, every single person on Earth would have to have been an ancestor of our hypothetical starting person. Once these 2 datasets cross over, we would know when, theoretically at least, every single person on the Earth at the time would have to have been an ancestor of this hypothetical person. So, what does the data show? Once we get back to about 1100 CE, we would theoretically have just over 1 billion ancestors. By contrast, the population of the world at the time was about 398 million. This would therefore mean that our hypothetical individual would have more ancestors than there were actually people on the planet, meaning everyone who had descendants at that time would have to be this person's ancestors. Now, I know I've used a hypothetical individual here, but the basic point I'm making would apply to anyone. As Adam Rutherford pointed out, as reported in a Scientific American article, anyone who has European ancestry is a descendant of Charlemagne. As another example, researchers have shown that every individual who became a parent themselves 1,000 years ago became the ancestor of everyone who had ancestors from Europe. What I will say is that, although my thought experiment shows the general point, this same research I referenced mentions that the generation where everyone was an ancestor was 3,400 years ago. So, in about 1400 BCE, rather than the 1100 CE we came to in our calculation. However, although there is obviously more nuance to these calculations in real life, The point we made today was highlighted in the article discussing this research, when researcher Peter Ralph pointed out that at some point you would have 1 trillion ancestors while there were fewer people alive, meaning some of your ancestors have to appear in your tree more than once. I'll have to come back to the actual research side of this in a separate episode, but the maths of everything we've discussed today is certainly interesting. That brings us to the end of today's episode. As always, thank you all for listening. Feel free to get in touch at the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.